Hello, Pre-Calculus Block 3 class and Mrs. Ward. I'm Allie Bruno here with Mackenzie Klinger and Marita Heichel. Today we will be presenting our project on the curious incident of the dog in the nighttime.
Today we will be explaining to you the problem having to do with triangles on page 214. Here's the problem. A triangle with sides that can be written in the form of n squared plus 1, n squared minus 1, and 2n, where n is greater than 1, is right-angled. So you need to show by means of a counterexample that the converse is false.
Converse means the if and then parts of a sentence are switched. It is a reversed hypothesis. The original states if a triangle has sides that can be written in the form of n squared plus 1, n squared minus 1, and 2n where n is greater than 1, then it is right-angled. So, what we need to prove wrong is, if a triangle is right-angled, then the triangle has sides that can be written in the form of n squared plus 1, n squared minus 1, and 2n where n is greater than 1. So, we need to find a right-angled triangle, but whose sides cannot be written in these forms. To find which side will be the hypotenuse, the longest, plug in a random number that is bigger than 1 to each of the equations. Let's use 2. So plugging in 2 for n, the first equation we have 2 squared plus 1 equals 5. The second equation we have 2 squared minus 1 equals 3. And the third equation we have 2 times 2 equals 4. The n squared plus 1 will be the hypotenuse, or the biggest side.
So the reason this is going to be our biggest side is because when we plug the 2 in for n, we got a 5, which is bigger than 3 and 4, and so that is the longest and thus our hypotenuse. So the Pythagorean theorem states that a squared plus b squared equals c squared. So let's let AB, the hypotenuse, be 65 and BC, be 60. So you can pick any numbers for this, but we just chose these ones. So to find CA, we can switch the variables in the Pythagorean theorem around just using basic algebra. So to solve for A, subtract over the b squared. Then take the square root of the whole side. So after this basic algebra, you get A equals the square root of c squared minus b squared. So then we're going to put into this equation the appropriate side length. So we're solving for CA, so it's going to be CA equals the square root of AB squared, because this is our hypotenuse, and then minus b squared, which is the other side. BC squared, which is the other side. So then we're going to put in the appropriate values for AB and BC. So we have CA equals the square root of 65 squared minus 60 squared. And when you work all this out, you're going to get 25. So if AB equals 65, and it can be written in the form n squared plus 1, then n squared plus 1 equals 65. And so just using basic algebra again, you can find that n equals 8 from this. So now we're just going to plug in 8 for n and all the other equations. So for BC, you have 8 squared minus 1, and that equals 63. For CA, you have 2 times 8, which is 16. And then we already solved for AB above. But wait, earlier we said that BC equals 60 and not 63. And since BC is a part of the CA equals the square root of AB squared minus BC squared equation, then CA also no longer equals 25 due to one of its variables changing.
So because the original measurements do not match the measurements we got at the end, the triangle is right-angled, but it does not match the forms n squared plus 1, n squared minus 1, and 2n.
So the reason we know that this is a right triangle is because in our very first step to find the hypotenuse, when we plugged 2 into every equation, we got the values 3, 4, and 5. This is a Pythagorean triple, meaning it is automatically a right triangle. So we proved that these forms also didn't work, so that is why we have proved the converse is not correct.
Here are the sources we used. Thanks for watching, and in the wise words of Mrs. Ward, math is fun. Enjoy your day!